Alright, student, let us start today's topic, that is inverse trigonometry, right? So this is one of those topics which is again asked at JEE Mains, but not at that difficulty level as we think of. So it is again a scoring topic, and let's see what all topics we have to do in this particular chapter. Alright. So first of all, what do you understand by inverse basically? So when we talk about inverse, or basically it's a class of basically inverse functions, right? So as we did in case of inverse functions and topic functions, so let's say if this is a function, okay, where it takes some input and results you some output, right? So this is now output. Now what you want to do is that you want to get back to the input from this particular output. Let's say this is the F machine. Okay, now if there is a machine which can reverse this process, that is, it takes this particular output as its input, right, and returns you same or similar input, right? It could be the same input or the similar kind of input that we put here. So this now becomes the input end and this now becomes the output. So it has inversed the process. That is why they are called inverse functions, or generally represented by F inverse, right? So here we are going to talk about inverse trigonometric functions. So for example, you people must have studied y equal to sine inverse x or cos inverse x or tan inverse x, and similarly the three more functions can be there for the trigonometry. Now if we want to compare them with y equal to sine x, and let's say we are comparing y equal to sine inverse x, so what are the basic differences that we need to highlight in these two particular inverse functions? So first of all, see here the value x here x comes to be an angle, right? X is the angle and y is your numerical value, right? It is a numerical number. This is the output. Whereas if you see here, what is happening here, x is your numerical number. The reverse will happen now. It is numerical, and y, the answer that you will get should be an angle. That is the inverse process. Okay, that is why it is called inverse. So if this is your, let's say, sine x machine, right? So this will be your sine inverse machine. So that means whatever output will be here will become the input for this. So for example, if you say that you will put x equal to pi by 6, so what the answer would be here, output would be 1 by 2. So if you input 1 by 2, then your output will again be pi by 6. This is the flow chart. This is the meaning of inverse functions. So now how you have to understand domain and range. So now coming to the point and leaving the basics apart. So domain and range of inverse functions, how you have to remember them, I can tell you a trick for this. Okay, domain and range of inverse trigonometric functions. So for understanding the range of, or sorry, the domain of inverse functions, it is very simple. For domain of inverse functions, you don't have to remember, actually you already know all of them. So what is the range of your sin x? Range of sin x is -1 to 1, which is nothing but domain of inverse. So basically range of a normal trigonometric function becomes the domain of inverse function. Similarly, the cos x will be -1 to 1, tan all real values, cot all real values, cosecant take values from -infinity to -1, union 1 to infinity. This becomes the domain of inverse function, and similarly the same answer is for the secant. So all these all values are basically domain. So this is basically, if you want to write, so this is the domain of sine inverse x. So that means sine inverse machine will work only when its input is between -1 and 1. This is the for cos inverse, this is for tan inverse, this is for cot inverse, cosecant inverse, and secant inverse. But remember, so what relation we have used here is that range of normal trigonometric functions, nt is now I'll call normal trigonometric function, is equal to domain of inverse trigonometric functions, right? Okay, but this is true, but this is not true that if you say domain of nt, that is normal trigonometric function, is equal to range of inverse trigonometric function, this is not true. Never apply this condition. Okay, so for doing the domain, or sorry, we have done the domain. For finding the range of inverse functions, right? For range of inverse functions, so For range, I'll not be getting into the depth of this particular topic, because for range we actually solve principal value branch, which you must have studied at CBSE also. So we study something called principal value branch, in which this function is a function. Why we study principal value branch, I can just give you a hint, because in this particular range it acts as a function, otherwise it will not be a function, and we are going to study inverse trigonometric functions. That is the target. So how do you remember principal value branch or the range of inverse? Now I'll tell you. So divide this into two particular incidences, or let's say two families. So I will call one as the sine family and the other as the cos family. Okay. What are the members of your sine family? So members of sine family are sine inverse, right? Then you have tan inverse, which is a member also, and cosecant inverse. So these are the members. For cos family, your members are cos inverse x, then you will have cot inverse, and then you will have secant inverse x. So these are the members of the cos family. So if you want to find the range, so for the range you just need to figure out the head member of the family. If you can remember the values of these, then all the remaining will be understood by them. So the range of this, if I want to talk about range, so for the sine family, if you just remember this sine, the sine has a range of minus pi by 2 to pi by 2. So whatever answers will come in, that means they should come in from minus pi by 2 to pi by 2. That is the fourth quadrant and the first quadrant. Remember the quadrant wise also. So for tan, and similarly for cos inverse, what you have to remember is 0 to pi. That is the first and the fourth quadrant. So I am writing quadrants also, fourth and first quadrant. Here it will be what? It will be first and the second quadrant. So whatever answers you will give will be among 0 to pi. Now if you want to find the answer for tan inverse, the same answer will be there, just change the bracket. So this was the closed bracket, this will become open bracket. For similar for cot inverse x, it will be same stuff, just change the brackets. Okay. Now if we want to talk about cosecant inverse x, repeat the value of sine, right? That is the sine, and subtract the middle value. So what is the average of these two? It is 0. Subtract 0 from the answer. Similar stuff here. Repeat the value of cos, subtract the average. Average is pi by 2. Just subtract this value particularly. So this is how you can remember the range of all the inverse trigonometric functions. Okay. Now what do you understand by this principal value branch? How you have to also make sure that you apply them into the question. Let's see this. Okay. So the logic behind this is that if when I say that sine inverse x, the answer to this will lie from minus pi by 2 to pi by 2, right? So if you have negative value of x, so when x is less than 0, just understand the answer will lie, so the output or the answer will lie in the fourth quadrant, right? That is from minus pi by 2 to 0. And when x is positive, your answer will lie in the first quadrant, that is 0 to pi by 2. That is the meaning. And this is valid for all these three family members, right? So if I talk about cos inverse, so cos inverse x takes value when x belongs to 0 to pi. So if x is positive, the answer output will be a first quadrant angle. So your answer output will be from 0 to pi by 2. Remember this. Okay, and when x is less than 0, your answer should come out in the second quadrant. So this is the change, that for sine family members, negative input will give second quadrant angle answer. Remember, the answer to inverse functions are angles, right? Very important. That is why I have highlighted it again. So output in the cases of inverse is basically angles, which are generally in terms of, yes, radians. So answer is radians actually. Okay. And if cos is there and the input of cos inverse function is negative, you will get answers in second quadrant. Okay. That is the second quadrant. Okay. Okay, the next thing that you people have to remember is the graphs of inverse function. So this is the graph of the sine inverse machine, and you can see that it is only lying between minus 1 to 1 as we did earlier. So if you have to remember them along with their domain. So domain of this function is nothing but it works only when the input is minus 1 to 1. And what is the range of this function? can you see the graph is going from minus pi by 2 to pi by 2. That is the range. So this is how you have to remember entire curve. And you can see that for negative inputs, the answer lie in the minus pi by 2 to 0, 0, that is the fourth quadrant. And for the positive answers, x, the value is from 0 to pi by 2. Similarly, this is the graph of cos inverse function. Cos inverse x is always above x-axis. That means the value of y is always positive. We know that fact. Domain, as you can again see, is from minus 1 to 1. Right? It goes from minus 1 to 1. Now the difference is at x equal to minus 1, the value is pi. So if you are confused that how this value comes out to be minus at x equal to minus 1, the value comes out to be pi, you can see it from example here. So understand the function is y is equal to cos inverse x, right? I say y is equal to cos inverse minus 1. So how you find this value? Just take cos inverse on other side. So this becomes cos y is equal to minus 1. When the value of cos is minus 1, that is pi. So that is why we say y is equal to pi. Very basic stuff. And the range, as we did earlier also in the rule, is nothing but from 0 to pi. You can again see that for x negative, so this point of intersection you people have to remember again, this point of intersection here is pi by 2. So for negative value of x, it is taking values from pi by 2 to pi, and for positive values, it is taking value from 0 to pi by 2. The next case is that we are going to talk about, this is the tan inverse x case. We know that the domain of tan inverse x is nothing but x belongs to all real. So that is why this is graph is for complete real axis. But the range is limited. The range only lies from minus pi by 2 to pi by 2, where pi by 2 and minus pi by 2 are open brackets. That is why they are dotted and they are nothing but your asymptotes, right? Remember this. So these are your asymptote. This is also asymptote and this is also your asymptote here. Okay. Next graph that we have to do is, this is nothing but y equal to cot inverse x. Right? Remember this. So for cot inverse x, do you remember that domain is nothing but same as cos inverse, just we have to, range is nothing but equal to cos inverse, just change the brackets. So 0 to pi, so this 0, so that means x-axis here is asymptote. So this is your asymptote and this is also your asymptote. Okay, and it is again, domain is again what? All real values. It will be the complete function. Again notice that this is always positive, but at pi by 2 it intersects the y-axis. So for negative values of x, so this is negative x. For negative x, the answer will lie between pi by 2 to pi, and for when it is positive, the answer will lie from 0 to pi by 2. Alright. This is the graph of y equal to secant inverse x. Secant inverse x, again we know the domain is same as what we did in case of range of, yes, minus infinity to minus 1 union 1 to infinity. You can see that this is happening here. So it starts from minus 1 here, x equal to minus 1, right? This is x equal to minus 1, goes till infinity, that is x equal to 1, then it goes towards infinity. Okay. And the range we have already done. So range is nothing but, what is the range? Secant inverse x will follow the graph of, yes, it is the cosine family. So it will be nothing but 0 to pi, but it will not take the value 0. You can see, so x equal to 0 here is an asymptote. That means, sorry, y equal to 0 here is an asymptote. Okay. Similar stuff happening here. Domain of cosecant inverse is nothing but range of cosec x, which is again minus infinity to minus 1 union 1 to infinity, and the range is, yes, it's belong to sine family. Sine family range was minus pi by 2 to pi by 2. Repeat the same but subtract the average. So average is nothing but 0. Sorry, so I made a mistake here. It should not be 0 here. My bad. It is pi by 2. So it is not y equal to 0 that I have told you. Here it is pi by 2 line, right? So here x, this is actually wrongly written. This is the x-axis here, right? Let's take a basic question to understand the concept. So it is tan inverse 1 plus cos inverse minus 1 by 2 sin inverse minus 1 by 2. Let's solve individually. So what is tan inverse 1? So you can say this is y is equal to tan inverse 1, or you can say tan y is equal to 1. So what value of y will be there? Yes, it is pi by 4, right? So if you want to talk about cos inverse minus 1 by 2, so just think of the what is the shortcut that I can tell you here is, when will be the value of cos 1 by 2, at what angle cos gives you 1 by 2? Yes, it gives you value at 60 degree, but it is minus sign. So just write pi minus what? Pi by 3. This is 2 pi by 3. But because it is in the negative sign, so angle should come out in the second quadrant, remember? So cos inverse negative returns you a second quadrant angle. Sin inverse negative. Sin inverse negative will return you which particular angle? Fourth quadrant angle. This is again you need to remember. And just think of, when the sine inverse or sine becomes 1 by 2, sine becomes 1 by 2 at, yes, pi by 6. You want what? Fourth quadrant angle. So this will return you minus pi by 6. So the answer to this particular problem is nothing but pi by 4 plus 2 pi by 3 minus pi by 6. This is how you are going to answer this particular problem. Okay. So in this chapter we have to majorly cover properties of inverse trigonometric functions, and the first property that we are going to do in this slide is, so this is I called as T inverse T, that is inverse trigonometry, then inside is the normal trigonometric function is nothing but theta. This is the value. Okay, but now this is something very important. So what is the important point here? What is the important thing is that this theta has to lie in principal value branch. This theta has to lie in principal value branch. This is something very important, otherwise your answer will be wrong. You can say principal value branch or you can say range, it's one and the same stuff, right? Whatever way you want to understand, right? Which range? The range of inverse function, that is this outermost T inverse function. So T inverse T function will give you theta only, but it should satisfy the principal value branch of T inverse function. So for example, you can see here sin inverse sin theta will be theta only when theta lies between sin pi by 2 to pi minus pi by 2 to pi by 2. Cos inverse cos theta will be theta when it lies between the principal value branch of cos inverse, that is 0 to pi, and similarly for the other 4 angles. Alright, let's see this application in question straight away. So the first question is that sin inverse of sin 2 pi by 3. So I have seen students generally writing straight away 2 pi by 3, which is not the answer. Why this is not the answer? Because what is the T inverse function here? T inverse is nothing but sin inverse. What is the principal value branch of sin inverse? It lies from minus pi by 2 to pi by 2. So whatever you write here, right, should fall in the category of minus pi by 2 to pi by 2, which is not the case. So we need to convert this first of all into your principal value branch problem. So how you are going to do this? It is that this is sin inverse sin 2 pi by 3, right? What can you write about 2 pi by 3? Can you write pi minus pi by 3? Absolutely same stuff. And what is sine of pi minus theta? Yes, so sine of pi minus theta is nothing but what? Yes, so it becomes sine pi by 3, right? And now if you apply the formula, and if you say the answer is pi by 3, this is correct because this satisfies the principal value branch over here. Now let's see another problem here. It says cos inverse of, it says cos inverse cos 7 pi by 6. So again, immediately you can see the answer will not be 7 pi by 6, right? Because it does not lie in the principal value branch, which is the answer should have been in the range 0 to pi, which is not the case. So what will happen now? Again, I'll try and convert this into the principal value branch first of all. So it becomes cos of pi plus pi by 6. This is what you can write. And what is pi plus pi? Cos of pi plus theta? Yes, it is minus cos theta. Can we say this? Right? This is how it will be treated. Okay. Though I can teach you how are we going to do this, but since I have not told you the property of minus inside, just put the, how you are going to solve this, you just put the value of what is cos pi by 6, it is minus root 3 by 2, and now you can easily tell me what is this answer now. Yes, so the answer to this particular problem then will be 5 pi by 6. Okay, people who have already done the property that minus sign taken, so just to reiterate, so cos inverse minus x is nothing but pi minus cos inverse x. We are going to do this, so don't worry. So this you can also clearly see that this particular answer can still be matched like this here. Okay, but never writes exactly the value which is given inside theta. Just check whether theta lies in the principal value branch or not. Okay. Okay, let's take the next problem. It says find the value of cos inverse cos 10. So first of all, what is this 10? So 10 is not in degrees, remember. So this is radian. If nothing is written, so I'll take this in terms of, first of all, this is radian measure, right? So radian. So for second step is that it is not equal to 10. For this equal to 10, it should have lied in the range of 0 to pi, and we know that what is pi? It is nothing but something 3.14. So it is way beyond the range, right? Approximately, right? It is way beyond the range, so 10 should not be the answer. So now how we are going to attempt this particular problem is that we'll try to convert 10 in this particular range, that is 0 to pi. For that we need to figure out what is 10 radians, the approximate value of 10 radians. Where is 10 radians lying, or what quadrant the 10 radians is lying? So we know that pi is 3.14, right? And if we do something of 3 pi, right, what will be 3 pi? It will be 9.45 something, right? We can say approximately, whatever might be the value. I'm just doing an approximation, very random approximation. So this is the value. So that means 10 is greater than 3 pi, right? So now what is 3 pi? So if we take the quadrant system, so this is 0 degrees, this is then pi degree, then full circle is 2 pi, and then again you will come here, this will become again 3 pi. So 10 radians. So this something is 10 radians which lies in the, so this is 10 radians first of all, right? Something like this. So 10 radians is something which lies in the third quadrant, which we do not know how to solve. Okay, so how we are going to solve this then? Okay, now let's apply some trigonometry here. So it says, so if this is greater than 3 pi, so the answer lies in this particular theta. So, and it is a third quadrant angle, so this will be something, the value should come out to be negative. That is what we understand. So there are two ways which you can express. You can say 3 pi plus theta equal to 10, right? This is what you can say, right? This is the value, or in fact there is other way of saying. So what this value will be, if you take the full circle twice, this will be 4 pi, right? And if you say 4 pi minus 10, so this, the angle would be what? Or the other way of saying 10 degrees is, if you take, measure it, what, anti-clockwise is one step that you can measure, right? Which we do here, which is done here. Or you can measure 10 degree clockwise also. There are two steps, right? So if I start measuring clockwise, so this, let's say angle is alpha, right? So you can say that it will be nothing but equivalent to 4 pi minus 10 degree is equal to alpha. This is also, I can say, this is also what will be the 10 degrees. Okay, so if you want to calculate cos 10, there are two methods now. Either you can say it is nothing but cos of what, 4 pi minus 10. Can I say this? In fact, yes. So if you people are still struggling to understand this concept, okay, so let's put a negative sign here. Why negative? Because we know that if you start measuring angles clockwise, the angles are taken negative. But since it is cos, so inside cos minus theta, we know that cos minus theta is nothing but cos theta only. So this becomes what? Same, that is cos 4 pi minus 10. Now if you see, what is the range of 4 pi minus 10? 4 pi minus 10 belongs to 0 to pi. That is not a problem. Now this is in the principal, so this implies this is in the principal value branch, PVB, principal value branch. Now if you just replace this particular value, so this answer becomes cos inverse cos 4 pi minus 10, right? Because you have just replaced the value of cos 10 as cos 4 pi minus 10. So now if this is in the principal value branch, the answer to this particular problem is nothing but 4 pi minus 10. This is the answer we were all looking for. Now I have seen students who struggle and say, sir, I want to follow this particular approach, that is 10 is equal to 3 pi plus theta. Let's start this then, that's not a problem. Let's take cos on both sides first. Cos 10 is now cos 3 pi plus theta, right? If you do this, how do you solve cos 3 pi plus theta? Cos 3 pi plus theta is nothing but pi plus theta, one and the same stuff. right? And this becomes nothing but minus cos theta. So where you land up with, you are going to solve cos inverse minus cos theta, and we just did earlier also, and we will be doing this in the formula section as well, the other property, that cos inverse minus x is nothing but pi minus cos inverse x. This is the property. Okay, so if we know this particular property, what this value would return us, this will be pi minus cos inverse cos theta, right? Or we can say pi minus theta. What is the value of theta from here? You can say theta is 10 minus 3 pi. Just put the value. So this answer becomes pi minus 10 minus 3 pi, and if you solve this, this again becomes 4 pi minus 10, which is completely similar to this answer that you are fetching here. So both the methods are correct. This is one of the most simpler approach, right? This is one of the simpler approaches. That is why we do this earlier. Okay, but otherwise you can also solve by this method also. Okay, let's take the other properties of inverse. The other property that you people have to remember is, now we did T inverse T. The other property is T of T inverse, right? So T of T inverse is also theta. So for example, sine of sine inverse theta is again nothing but theta. So it is, we are comparing this with sine inverse sine theta. This was also theta. Now the only condition change was that theta here was in the principal value branch. Here theta must lie in the domain of inverse. This is the change, right? It should lie in the domain of the inverse function, and that is pretty much obvious. Why? Because you can notice here that theta in this is with inverse function. So if this does not lie in the domain of inverse machine, this machine will not work. So that means sine inverse sine x is equal to x only for when x lies between -1 to 1. So if somebody gives you this answer that sine of sine inverse 3, what is the value? The answer is not 3. Why? Because 3 is not in the domain of sine inverse 3. This is not solvable, not defined quantity, because you cannot put 3 inside sine inverse. That is what is meant by the property. Okay, so all these formulas are x depending on what is the value of x in the domain of the inverse function. Next property that you people have to understand is the negation property, which we have already applied earlier in the problems. So sine inverse minus x is nothing but minus sine inverse x, and we'll understand this by the sine family rule. So all the sine family members, we did the sine family was nothing but sine inverse, tan inverse and cosecant inverse. So they all follow the same stuff, that is minus. So the minus sign will be taken outside. That's it. Similarly for tan inverse minus x, what you will write is minus tan inverse x, and similarly cosecant inverse minus x will be nothing but minus times cosecant inverse x. Whereas the cos family, so what is the rule of, let's say now we talk about the cos family. So cos family says that if there is inverse negation, what you will do? Pi minus cos inverse x, right? The same rule is applied for cot inverse minus x, right? So if cot inverse minus x is there, you will do the same stuff, and the same stuff will be repeated for secant inverse minus x, which is the third member of the cosine family. Okay, so you can just remember all these properties using sine family and cos family. Okay, let's take questions on the properties that we have done. So the first is that tan inverse, so this is the equation that tan inverse under root 1 minus cos x, let's say divided by 1 plus cos x is given to you to be solved. Okay, you need to find the value of this, where x is given that it lies between minus pi to pi. So you need to find this particular value. So now how you have to understand solving these questions. So the outermost function is inverse function. So your target is to figure out T inverse T is equal to theta type problem. So that is, if I want to give you a hint, outermost function is tan inverse. Whatever is here inside, right? Let's say this is some fx. I don't know what it is. You need to try and make this fx into the form of tan, right? So that I can apply tan inverse tan and the answer will come out to be theta. This is the target. So the innermost function here is nothing but tan inverse under root. So what is 1 minus cos x? Yes, it is nothing but 2 sine square x by 2, and this is nothing but 2 cos square x by 2. And if you solve this, this is nothing but tan inverse, and this 2 and 2 cancels out, becomes, yes, tan square x by 2. This is the value, and this comes out to be very easily tan inverse tan of x by 2. Since the x lies between, it is given that x lies between minus pi to pi. What is the domain of x by 2 then? Minus pi by 2 to pi by 2. So this is basically in the principal value branch of tan inverse. So I can easily apply the formula x by 2. So the answer that I should be looking forward to is x equal to y equal to x by 2. This is the answer. But mind it, this answer is wrong. Why? It is only the half answer. Why? Because let's come here. This is the problematic step. So you have actually missed one of the solutions here. Whenever under root is there, what you will do? Yes, you will have to place a modulus sign. Right? This is how you will have to write this particular step. And now this questions break into two fragments depending on the value of tan inverse, tan x by 2. So if tan x by 2 is positive, this is the value, then x by 2 is positive. So when is tan x by 2 positive? When x by 2 is in the first quadrant, that is greater than 0, right? And when tan inverse, you should write like this, when tan x by 2, this is negative, right? This is the answer. Okay, so this is how you have to start thinking on the questions now. When x by 2, so this is when this thing will happen now. So tan x by 2 is negative. This is only possible when x by 2 is between minus pi by 2 to 0, that is the fourth quadrant. This will be only happening when this is between greater than 0 and less than pi by 2. So you have solved this answer. So if you say this here, then it's not a problem. So here x by 2 lies between 0 to pi by 2, which is in the principal value branch. So answer to this particular is x by 2. But the answer to this problem will be now something different. Why? Because you have tan inverse minus tan x by 2, right? So this minus will come outside now. If this minus comes outside, this becomes minus tan inverse tan x by 2, right? Where x by 2 lies in the range minus pi by 2, which is again in the principal value branch of, yes, so answer now will be minus x by 2. So you can see you will get not one answer but two answers. So the answer are 2 depending on the value of x. So x by 2. So what you can say, when x lies between, yes, so here was the answer. So here x lies between 0, or I can say what, 0 to pi, if this the answer is x by 2, or you can say minus x by 2 when this is the answer, that is minus pi by 2 to 0, but we want to find the value of x, so x lies between. These are the two answers that you people have to mark in the exam. There is no one answer in this particular question. And now let's take the other question, which is now based on substitution, right? So again, if you see, this problem is something of t inverse outside. You need trigonometric function to get theta, right? This is the target. Now we have t inverse here. The outermost function is tan inverse, right? Now the problem is that this t is not a trigonometric function, whereas this is now a algebraic function, right? So how you should understand this is that now target is to convert this algebraic function into trigonometry, so that I can again go on and apply tan inverse t inverse t is equal to theta problem. So here this x square is the problem. So I can take x square equal to what value you can think of. Just give me a hint. Yes, you can just take this as cos 2 theta. Rather than taking cos theta, I prefer taking it cos 2 theta. Why? Because it's obvious. Because when you say this particular range, right? So what will be the value then? This will be 2 cos square theta, not the standard that we do, that is cos theta by 2. So that is a challenging stuff. And 1 minus cos 2 theta is nothing but 2 sine square theta. These values we all know. Now you have under root here, right? So what will be the value of the under root? Yes, so under root will be nothing but, tell me please. Yes, so if you take the under root, 1 plus cos theta should come out to be root 2 cos theta. Okay. Now you people must be wondering that I should have taken a mod here. Why I have not taken a mod? See here, x square is always positive, so you cos 2 theta is always positive, right? That is the challenge. So if 2 theta is always cos is always positive, that means 2 theta lies in the first quadrant, then theta obviously lies in the first quadrant. So that is why I have not taken a modulus sign, because it is already positive here. Okay, then similar logic, that this 1 minus cos 2 theta here will then become root 2 sin theta, right? Now you have 1 in the numerator that is being added up, so this becomes cos theta plus sin theta, and root 2 can be taken common, right? Root 2, and the denominator also you have the same stuff, that is cos theta but with a negative sign minus sin theta, then you have root 2, and outside this you have tan inverse, right? This is the value that you people have. Now if you go on and solve this, what this becomes, let's see. Now can you see we are doing what was actually required. We wanted to convert this into a trigonometric problem. Now your inside function has actually converted into a trigo problem. That means we are on the right track. So this becomes what? Nothing but a function similar to what this will reduce to. This will be sin theta plus cos theta divided by what it is, cos theta minus sin theta. Now how do you resolve this? Yes, very simple stuff. You all have done this in basic trigonometry. Divide by cos, this becomes 1 plus tan theta upon 1 minus tan theta, and we know that this is nothing but the formula of, yes, tan pi by 4 plus theta, right? This is the value which we can say. Now the answer that we can easily see is now that this becomes pi by 4 plus theta. Now can we say this directly? Now let's see. For this we have to go back here what we did here. So x square is equal to cos 2 theta. Let me write it again. So x square is equal to cos 2 theta. So x square is positive, right? That means cos 2 theta is positive. That means 2 theta must have been in the 0 to pi by 4 pi by 2 category, right? Then theta must have been in the this particular branch, right? Now you have added pi by 4 here, so this becomes what? Adding pi by 4 entirely in the inequality, this becomes theta plus pi by 4 will be less than pi by 2. Yes, so that means this answer is correct. Why I can say this answer is correct? Because it lies in the principal value branch of tan inverse. The principal value branch of tan inverse is 0 to pi by 2, which is this particular range. Pi by 2 to pi by 2 is the subset of this. So that makes complete sense. This is the answer. Now just put the value of theta back. So theta was nothing but, what is the value of theta? Yes, it is 1 by 2 cos inverse x square. So this is the answer that you have to select in the exam. Okay. Next particular set of properties that we have to do is the inverse set of properties. So sin inverse 1 by x is nothing but cosecant inverse x, or the vice versa, cosecant inverse 1 by x is sin inverse x. Similarly for cos and secant pair. But now you have to remember a special formula for tan inverse 1 by x. So tan inverse 1 by x is nothing but cot inverse 1 by x, right? This is only valid when x is positive. But when x is negative, right, that is tan inverse x here when x is negative. Now what you people have to remember is something different. This will be minus pi plus cot inverse 1 by x, right, when x is negative. So for x negative, this is a special case where minus comes in. So I can say tan inverse 1 by x, or here, so do not worry whether this is x or 1 by x, you can replace them because this is identity. But just check that if x is negative, for cot inverse you will get what? A minus pi sign. And you can easily understand this by the fact that we know that cot inverse x always returns positive, value, right? Always returns positive value. Why? Because its principal value branch is 0 to pi, and this will be negative because x is negative. So for somewhere you have to make RHS also negative to make them equal. That is why you are adding minus pi. Remember like this. The other important property is that sine inverse x plus cos inverse x is equal to pi by 2, something similar to what you did with sine square x plus cos square x equal to 1. Similar property is then, so all the complementary pairs actually if added under their domain, right, will give you answer as pi by 2, very important property. Let's see their application straight away in the questions then. So now let's take this question. It says that cos of, now inside is 2 cos inverse x plus sine inverse x, and we need to find the value when x is equal to 1 by 5. So now you can see here inside this particular there is hidden 1 sine inverse x plus cos inverse x, right, and we know that that is nothing but straight away pi by 2. So this question then reduces to cos of 1 cos inverse x will be left, right, and the next these two will get to pi by 2. So this is nothing but, we know that this is theta because this is an angle, this is an inverse function, so inverse function is nothing but the theta. What is cos pi by 2 plus theta? Yes, it is minus sine theta, which is right. So now this is of the form t inverse, right? We know t inverse is equal to theta, but we need the same trigonometric functions on inside and outside. Here one is sine, the other is right. So here now your target is to convert one of them into the other. We can easily do this. How you can do this? Tell me now. Okay. Let's see this process then. I'll be converting cos inverse into your sine inverse now because I cannot change too much about sine here. So how do you convert cos inverse into sine inverse? Very generic process which is also used here. So let's take this cos inverse. So we know that cos inverse x is nothing but an angle theta, right? So that means cos theta is given to be nothing but x. So if I take a right angle triangle, right, something like this, and say that this is theta, right? So what is cos theta then? Cos theta is what? Based upon hypotenuse. So let's say this is 1 and x and this is 1. So what will be this particular value? Can you tell me? This will be nothing but under root 1 minus x square. And if this is there, what will be the value of sine theta from here? Sine theta will be nothing but under root 1 minus x square by 1. And you can say that theta is nothing but sine inverse under root 1 minus x square. So this is how you convert any trigonometric value into its different trigonometric function. So for example, cos inverse x was given. Now I have converted that same cos inverse x into sine. So let's suppose if you wanted to convert this into tan inverse. So what will be the tan inverse? Tan theta will be under root 1 minus x square by x. This will be, this is also theta. So you can say this is nothing but equal to your cos inverse x. This is nothing but equal to sine inverse under root 1 minus x square. So all these quantities are equal. So just draw the triangle and convert whatever you want to convert in the formula. So now just put the value here and your question will be solved. So this is minus sine cos inverse is now sine inverse. Yes. So this is nothing but sine inverse 1 minus x square. Now the answer is nothing but minus 1 minus x square. You wanted the value at x equal to 1 by 5. Just put the value at x equal to 1 by 5. So this is nothing but 1 minus 1 by 5 square. That's it. Okay. So this is nothing but what you will get is minus 1 by 5 root 24. Okay. Which you can again simplify to get what? Minus 2 by 5 root 6. Okay. Okay, let's take the next problem. It says secant square. We have secant square now. Tan inverse 2. Similarly, you have cosecant square cot inverse 3. So this is again a very basic problem, and we have already done a similar problem on this way. Why I have taken this? I have seen students struggling to understand the square stuff here, which is very simple. You can just solve this and then square. That is the same stuff as saying the earlier step. Okay, so this is nothing but this particular question. Both these steps are same. Now you need to find secant inverse of tan inverse 2. So that means you need to convert tan inverse 2 into secant inverse form, which we just studied how we do it. So let's just quickly do it, and then we convert this into a triangle. So if this is theta, then this is 2 and this is 1, because we know that we have consumed that tan inverse 2 is equal to theta. What will be this value? This value will be what? Root 5. You want secant inverse. So what is secant inverse? So for those who are still struggling, I'll repeat. Secant inverse is just the opposite of cos inverse. So what do you do for cos theta? What is the value of cos theta here? Tell me. This is much more easy to solve. This is 1 by root 5. So the value of secant theta would be just the reciprocal, that is root 5. That means secant inverse theta would be secant inverse root 5 is equal to theta. Now I have converted the value of tan inverse 2 into secant inverse. Similarly, I'll convert this cot inverse 3 again by using the triangle 90 degree here, that is theta, and cot inverse. So cot inverse, I'll assume this is theta. So this implies this is cot theta is equal to 3. Cot theta is nothing but what? Base upon perpendicular, the opposite of tan, right? So this is 3 now and this is 1. So this becomes nothing but 1 root 10. Okay. And now you are asked to find, and now you want to convert this into your cosecant inverse pair. So first of all, figure out what is cosecant theta. So cosecant theta will be nothing but reciprocal of sine. Sine is 1 by 10 root 10. So this becomes root 10. So that means you can say theta is nothing but cosecant inverse root 10. So now you have got each and every value. Just put the values to get the answer. So if you were to find the answers would be something like secant of secant inverse root 5, then you will have whole square, then cosecant of cosecant inverse root 10 whole square. This is what you will have, and this is nothing but 5 and this is nothing but 10. The answer that we will get is 15. This is the answer that you will mark in the paper. Now let's take the other problem, which is a bit tricky. It says tan of 1 by 2 cos inverse root 5 by 3. This is what we want to simplify now. Okay, now there is the challenge that here there is the problem here is lying with this 1 by 2, right? We can convert cos inverse into tan inverse straight away, but this 1 by 2 will not go away. So we need to convert this, and for this let's do a simple calculation. First of all, what I'll do, I'll put this particular cos inverse root 5 by 3 as, let's say, 2 theta. So if I do this, this becomes what? Nothing but complete tan theta. So now target is, what is the target? Can you tell the target? So the target is to find theta in terms of something of tan inverse, and I don't know what this value will be, this, so that I can apply T of T inverse equal to dash problem, right? This is what is the target. So you have theta here, right? You need to convert this into tan inverse. So going back, what this reduces is to cos inverse. Okay, let me write the first step again here. So this becomes cos inverse root this is equal to 2 theta, or I can say cos 2 theta is equal to this. So now you should start thinking of converting this into the tan problem, because you want tan inverse here, and we know that there is a formula for cos 2 theta in terms of tan theta, that is 1 minus tan square theta upon 1 plus tan square theta is nothing but cos 2 theta. This is what I can say now, right? Or the other way around, that 1 by tan square theta upon 1 minus I just did the reciprocal. Okay, I'll because I like this way much better. Now you want the value of tan theta from here. Now this is again a completely trigonometric problem, and you want tan theta. What I'll do, I'll apply componendo dividendo. Componendo dividendo, that is, you add these two. So if you add these two, you will get 2. If you subtract these two, you will get 2 tan square theta. Similarly, apply componendo dividendo on the right hand side also. Right, this is what you are going to fetch, right? And you can now easily say that tan square theta is nothing but 3 minus root 5 by 3 plus root 5. This is your tan square theta, and tan theta will be then the under root of all this, that is 3 minus root 5 divided by 3 plus root 5. Now you have actually got the value of tan theta in terms of tan inverse. So this is theta is equal to tan inverse what? This entire value. Let me write this as some a, right? Now you have got this. Now the answer is you wanted to find tan of tan inverse a, and the answer comes out to be a. So this is the particular answer, which is nothing but under root of 3 minus root 5 by 3 plus root 5. Okay, which would be further resolved if you want to, which is if you just multiply both of them by 2 in the numerator and denominator. So this becomes something like this: 6 minus 2 root 5 upon 6 plus 2 root 5. So what can I say about, let's say, 6 minus 2 root 5? So this is nothing but root 5 square plus 1 square minus 2 root 5, which is a minus b whole square. And similarly you can do this. So the answer to this particular problem then can be written as root 5 minus 1 upon root 5 plus 1, right? The under root will go on, and then again what you can do, you can take the you can do the rationalization again to solve this particular step. So what this will become here, this will be root 5 minus 1 whole square divided by, this will be what, 4, and then you can again solve this. So this becomes what, 6 minus 2 root 5 by 4, and you can cancel out 2, so this becomes 1 by 2 times 3 minus root 5. So this is the final answer that will actually match in your exam sheet. Okay, and this is how you solve this particular problem. Okay, let's do the next property, which is the summation of tan inverse. So if you have both x and y positive, x tan inverse x plus tan inverse y is nothing but x plus 5 upon 1 minus xy. Now this is splitted into 2. Remember that if product is less than 1, then this is the formula. If the product is greater than 1, then you will have to add pi. Okay. Similarly, if you want to say tan inverse x minus tan inverse y, x minus y by 1 plus xy. There are formulas for sin inverse x plus sin inverse y also, which I do not prescribe because you will not be asked these kind of formulas in JEE Mains or at board level, right? So even if you don't remember, do not fret over them. So sin inverse x plus sin inverse y is nothing but sin inverse x into 1 minus under root y square. So if you want to remember them, I can tell you the trick again. So remember something of sine of a plus b. So what is sine of a plus b? It is sine a cos b plus sine b cos a. If you remember this, you can easily remember this here. Let's see how. So if I say sine inverse x for a, right, then for cos, what I will have to do, you will have to then multiply with 1 minus y square, then only you will get cos b. Similarly, if you say y, then cos a will be obtained by 1 minus x square. That is why this formula is there. So for minus, you will just put the minus. Similarly, for this, if you want to remember the formula for cos a plus b. What is cos a plus cos b? Oh, sorry, cos a plus cos a plus b. Cos a cos b minus sin a sin b. Right? So for this, what you will do, you will just put the formula as cos inverse x y, because you have taken them these to be x and y, minus under root 1 minus x square under root 1 minus y square. This is how you can remember them. Now let's apply them straight away in the question. So the first question says tan inverse x 1 plus tan inverse 2 plus tan inverse 3. So we know this value, this is nothing but pi by 4. So we need to solve now tan inverse 2 plus tan inverse 3. This is what you need to solve. So if you check here, so there were two formulas for tan inverse x plus tan inverse y, right? Depending on what is the product of xy. So here the product of xy is greater than 1. So the formula that you are going to be using is pi plus tan inverse x plus y upon 1 minus xy. Just remember this. This is the reason that this question is taking place here. So this is plus tan inverse, what the value is, 5 upon minus 5. This will be pi by 4. This comes out to be what? Pi by 4 plus pi plus tan inverse minus 1, which cancels out with pi by 4. The answer is pi. right? Remember, if you do not use this particular answer with pi added here, your answer will come out incorrectly as 0 because you will not put this pi. So the answer is pi, whereas the wrong answer that you will fetch -1 in the exam is 0. Okay, now let's take the next problem. It says a greater than b greater than c greater than 0. Then you need to find the value of cot inverse this, cot inverse this, cot inverse this, which is cyclic in order. You can say a minus b minus c minus a. So there is a pattern here. Now I can convert this problem into tan inverse problem because that is what I am comfortable with. So I can do this, right? Then I can do this tan inverse b minus c by bc plus 1, right? And then the last one can be written as tan inverse c minus a by ca plus 1. Okay, so because we know that tan and cot inverse are reciprocal pairs. Now if you see this particular first thing can be written as tan inverse a minus tan inverse b. Can you see this? Similarly, the other one can be written as tan inverse b minus tan inverse c, and the next one can then cyclically then be written as tan inverse c minus tan inverse a, and you can see that all of them gets cancelled out. The answer is 0, right? This is what you should mark in the exam, but as usual this is wrong. This is the wrong answer. This will fetch you in fact -1 and will be the problem. What is the problem is when you have come here in this particular step. Now what is happening? Let's see. It is given that a is greater than b greater than c. Here what is happening? C minus a. So c minus a is a negative quantity, right? We did tan inverse x is equal to minus pi plus cot inverse minus 1 by x. Remember, this is the property that we did. This is the property when x was less than 0. So here, since this is negative, c minus a, so c minus a by 1 plus ac will also be negative because a and c are both positive, right? This is given here. So this property has to be used here. So if this is the cot inverse, so I can say that means cot inverse x is nothing but pi plus tan inverse 1 by x when x is less than 0. So if you do this, there is no problem writing this, but the problem is we'll have to add a pi here, plus pi plus pi. The right answer that we were looking for is pi in this particular case. So now let's do next set of properties, which is properties of multiple angles. So for example, the first one, let's take the first one, that is 2 sine inverse x. So why I am saying this multiple angle, because I know that sine inverse x is nothing but a angle, right? It is theta. So is actually what is being asked is 2 theta. This is what you can interpret it. So if you want 2 sine inverse x in terms of sine inverse only, just write the formula of sine 2 theta. So what will be sine 2 theta? Sine 2 sine theta cos theta. So just write sine inverse 2 sine theta. So sine theta will be taken as x. Cos theta will then become 1 minus x square. So this is how you can remember these formulas. Sine inverse sine 2 theta, where x is nothing but sine theta. Just replace x equal to sine theta on both sides and you can check the answer will come out to be same. Similarly, you can do the other one, that is 2 cos inverse x. So this becomes basically 2 theta, and if I want to convert this 2 theta, so that is cos inverse. Now use cos 2 theta. Cos 2 theta is nothing but, yes, 2 cos square x minus 1. So this is the formula that you will use. Similarly, for 2 tan inverse x, again I would say this is 2 theta, right? Where x I will now substitute as tan theta, right? So what is the formula for tan 2 theta? Yes, it is nothing but 2 tan theta. So just place tan inverse 2 tan theta upon 1 plus tan square 1 minus tan square theta. Sorry, yes. So this is the formula. So this is the value that you will use for calculating this particular value. So we can also convert 2 tan inverse x into cos also, right? Or in sine pair also. Why? Because if you do this, you can say this is nothing but 2x upon 1 plus x square. Why? notice that if you put x equal to tan theta here, right, this will be converted to sine 2 theta, which will eventually give you again 2 theta as the answer. So no problems. Similarly, you can convert 2 tan inverse theta in terms of cos, right? You can say cos inverse 1 minus what? Theta square x square upon 1 plus x square, because if you again put x equal to tan theta, RHS will give you the value that is nothing but 2 theta, same. So this, let me just write this theta, oh sorry, x, right? So these are the multiple angle formulas when they are 2 theta. Now let's take 3 theta formulas. So 3 sine inverse x. So this, you can understand, this is nothing but 3 theta, because I'm going to substitute x equal to sine theta. So that means what I'm trying to do is finding 3, that is, so just replace the value of sine inverse and put the value of sine 3 theta. So what is sine 3 theta? It is nothing but sine, yes, tell me, yeah. So 3 sine x minus 4 sine cube x, this is the value, right? Now you know that you have taken sine theta to be x, so just put those values over here. So this is 3x minus 3 4x cube. That is the answer that you will write. So this is how you can actually learn all these formulas. So learning them and mugging them up is a bit easy task. Okay, 4x cube. Similarly, 3 cos inverse x can be remembered easily in terms of cos inverse. Just put the value of cos 3 theta in terms of x. So this is 4x cube minus 3x, and similarly I can say 3 tan inverse x is nothing but tan inverse what? 3x minus x cube upon 1 minus 3x square. Okay, this is how you can remember these all formulas. So for example, let's take this question. It says sine of 2 sine inverse 0.8. So now this is something of the sort t into t inverse, right? And we know that this is nothing but theta. But the problem is that between t and t inverse there is a multiple angle 2. So you want this 2 sine inverse, let's say x first of all, to get into terms of only sine inverse, and we know that we have a formula for this, which is nothing but 2x into 1 minus x square. So just substitute this value of x here to find the answer. So this can be simplified by something doing of this sort, where you will say 1 minus 0.64, right? And this 0.64 will then be converted to 0.36, right? And which is nothing but, you can say 2 into 0.8 into 0.6. That is the value that you have to calculate. So just now put the value. So you will get sine of sine inverse 0.96, which is nothing but 0.96. I can say this, why? Because it is also in the domain. 0.96 is in the domain of sine inverse x. So the answer that we should mark is 0.96, and that's the problem. Okay, let's take the next problem. It's that we want to again simplify this, and since it is sine outside, so we want something in terms of sine inverse, something like this, right? So if this is, let's say, x here, so this answer then will become x. This is the target. Now inside quantity, let me just see what it is. Tan inverse 1 minus x square by 2x plus cos inverse 1 minus x square by 1 plus x square. So this is the inside function. Okay, if you talk about, so how do you simplify this? We can easily see this particular formula, that if you start putting x equal to tan theta, right, what will be the value? This will be, let's see what this all will become. So this will be 1 minus x square by 2x. So this will reduce to tan inverse 1 minus tan square theta upon 2 tan theta, and we know this is nothing but 1 upon, this is nothing but formula for tan 2 theta, and I can write this as now tan inverse cot 2 theta, and cot 2 theta can be simplified as nothing but tan of pi by 2 minus 2 theta, the same stuff. And since tan inverse tan is there, so I can write this as pi by 2 minus 2 theta. Okay, so up till now this is solved. Let's solve the other component, that is cos inverse 1 minus x square upon 1 plus x square. So if this is there, let's see what is the value. If you put x equal to tan theta here also, because you have substituted x equal to tan theta here, so the same should be done here. So let's say this is cos inverse 1 minus, again this is the formula, and it's a very standard formula for what, 1 minus tan square theta. This is nothing but cos inverse cos 2 theta, which is nothing but 2 theta again, right? Okay, so up till that particular stage, what you have got now, if you clearly see, this becomes sin pi by 2 minus 2 theta plus 2 theta, and this cancels out. You just are left with sin pi by 2, which do not even require an inverse function. The answer is straight away 1. So the answer that you should mark in the exam is 1. Okay, now let's do a very important formula. So this is basically a formula that I am teaching you here, which is very important. This is tan inverse A plus tan inverse B plus tan inverse C. So there is sum of 3 tan inverse. So this could be for n also, and I'll explain what do you do when there are more than 3 tan inverse terms here. Okay, so the first thing that you people have to do here is S1 is sum taken at one at a time. Sum taken one at a time. Sum taken one at a time. So what do you mean by this? Something of this has been done in permutation combination, if you remember. So sum of the things taken one at a time, that is A plus B plus C, that is the value of the angles. So right, so values of these particular numericals A, B and C, sum taken one at a time. Then S2 is nothing but sum taken 2 at a time. Sum taken 2 at a time. So this will be AB 2 at a time, then BC, the other sum could be, and then CA. Right, now I think you have got hold of it. S3 is again but sum taken, yes, now this will be 3 at a time, that is A, B and C. There is no other term that you can form which will contain 3 distinct terms. So if you want to say, sir, I have, let's say A1, A2, and this goes on till n terms. Now let's say tan inverse an. So what the value would be? Tan inverse, the formula that you will use now is S1 minus S3 plus Si. So alternate positive negative, and the numerators will be all sum of odd, right? Sum taken one at a time, sum taken 3 at a time. And similarly in the denominator, 1 minus S2, then alternatively S4, then minus S6, and this is how this series will go on. And in the above also, I am writing it infinity, do not write it infinity. Let me just check this off. So this is how this series actually work in n number of cases. Okay, so let's see the application of this formula in straight away a question. So it is said that if x square plus y square plus z square is equal to r square, then find the value of this. So here the role of A is being played by, let's say, yz by xr. The role of B is being played by zx by yr, and C is nothing but xy by zr. So you need to find the value of tan inverse A plus tan inverse B plus tan inverse C. This is the task. Though there is no problem that you can take doing this, that 2 at a time, and then the remaining with this. You can also do this. This is not a problem, but I want to show you how the formula works in this particular case. So this becomes S1 minus S3 upon 1 minus S2. Let me just remove this. 1 minus S2. This is the formula because there are only 3 terms. Why I am doing this is, okay, let's do one thing. Whenever you find these kind of problems, first of all, the target should be to find S2 or the denominator question, whatever is there in the denominator. So S2 is nothing but AB plus BC plus CA, right? This is the value of S2. Now if you put those values, let's see what you will get. So this is what, okay, let me just start with putting value of A again. So A is nothing but yz by xr, yz by xr, into B will be xz by yr. Can you see what this quantity actually reduces to? This is nothing but z square by r square, right? Because y will cancel out, x will cancel out. Similarly, you can solve BC. So if you multiply these two terms, what will cancel out? See, z cancels out and y cancels out. So you actually get here x square by r square, and similarly I can say that the last term will be nothing but, if you do a and c, these two terms, so you will be left with what? Y square by r square. And if you see this, what it is? Nothing but x square plus y square plus z square by r square, and it is given to you in the question that x square plus y square plus z square is equal to r square. So this value is nothing but 1. So what is the value of the denominator in this now? So the denominator was 1 minus s2. Since s2 is also 1, this value comes out to be 0. So it is something of that, I do not know what is the numerator, there is something, but this becomes 0. So when does this thing happens? So this is, let's say if this is theta, what you will say, sir, there is something numerator divided by 0 is equal to tan theta. So at what value of theta does this occur? Yes, simply 90 degrees. So theta is nothing but 90 degrees. This is the answer straight away. So if denominator is 0 in the tan inverse, that means the angle is nothing but, your answer is pi by 2. Okay, that is how you have to solve these kind of problems. Now let's take the miscellaneous problems. Okay, so this question asks that if sine inverse x plus sine inverse y plus sine inverse z, right, is equal to 3 pi by 2. Okay, then you have to find this value. I'll talk about what this complex statement is, but before that, let's see. So what is the range of sine inverse x? Range, that means what the values it will return. Yes, we know that range belongs to minus pi by 2 to pi by 2. That means the max value that it can take, max value that it will return is pi by 2. And here you can see that three terms are being added and their value is 3 pi by 2, which is nothing but pi by 2 plus pi by 2 plus pi by 2. That means sine inverse x is also pi by 2, sine inverse y is also pi by 2, and sine inverse z is also pi by 2. Then only you can get the value 3 pi by 2. This means x is equal to y is equal to z. This is 1. So all the three values are 1. This is what is interpreted by this particular statement. So now what is interpreted here? Why the summation is there? So you can see there are long values here. Okay, but this statement is cyclic in nature because this is written only in terms of x and y. Only in terms of x and y. So there will be another term, right? So there will be another term which contains y and z, and there will be another term which contains z and x. That is why the summation sign is given. So this is basically summation or taken two at a time. Summation taken two at a time. This is what you can understand out of this. Okay, so if you just calculate this particular value, what this value would be, since all of them are 1, so 1 raised to power any value will be 1 anyway. So this is 2 into 2 divided by 2 into 2. Summation, how many times? The other one would also be the same stuff. So this is 1 plus 1 plus 1, right? So the answer is nothing but 3. That is what is required in this problem. So for summation you will have how many terms? 3 terms, right? Which contains which pair? Xy pair, yz pair, zx pair. All of them will return 1. The answer is nothing but 3. That's it. Okay, the next problem says that you are given cos inverse x by 2 plus cos inverse y by 3 equal to theta, and then you want to prove this particular equation that is written over here. Okay, so how you are going to solve these kind of problems? Let's assume that cos inverse x by 2, we know that this particular answer will be an angle, so I assume this to be a, and I assume the other angle, that is cos inverse y by 3, to be b. So from here I can say that cos a is nothing but x by 2, and this becomes cos b is nothing but y by 3. This is what I can say here. Okay, so now what the question now reduces to, this becomes a plus b is equal to theta. And if we take, if this is a plus b is equal to theta, what I can do now is I can take cos on both sides, that is cos of a plus b is equal to cos theta, right? So what is cos a plus b? That is nothing but cos a cos b minus sin a sin b is equal to cos theta. Now you know all these values. So cos a is nothing but x by 2 and this is y by 3. So this is xy by 6. What is sin a? Sin A is nothing but 1 minus x square by 4, and what is sin B? This will be 1 minus y square by 9, and this is nothing but cos theta. So up till now this is no problem. Let me take it over here and solve the problem here. So this becomes xy by 6 minus, this becomes what? Root 4 minus x square, and this is nothing but what? 9 minus y square again by 6 is equal to cos theta, and I can see this as x minus 6 cos theta is equal to root of 4 minus x square under root 4 minus 9 minus y square. So obviously this makes sense to now square, because we want to remove the under root. There is no under root in the question. So this becomes x square y square plus 36 cos square theta. This will be what? Minus 12 xy cos theta. So now if you see this minus 12 xy, this is there in your question as well. So that means somewhere down the line you are doing something correct. And this reduces to 4 minus x square into 9 minus y square. Now if you solve this, this becomes 36 9x square minus 4y square plus x square y square, right? This is what this will become. And if you see x square y square, this cancels out with this, right? Now you want 9x square 4y square, you can see here also. So I will take them on this side. This becomes 9x square plus 4y square minus 12xy cos theta. There is 36 here, and I'll take this 36 cos square on this side. And now you can see your question is solved. Why? Because this becomes 36 sine square theta, and I can say now hence proved. So this is how these type of questions are solved, where you are given cos inverse something, or this could have been sine inverse. You just assume them as a angle A and angle B, and then start solving as a normal algebraic or a trigonometric problem. But the next problem says something of infinite series, that is summation n is equal to 1 infinity tan inverse 1 upon n square plus n plus 1. So this pattern is somewhere very common with JEE advanced stuff, right? So if you talk about this question, this is easy as compared to JEE advanced, because this trick is being asked. But yes, you can find this in some other maybe website might ask this kind of, if they want to ask a tough problem. So let's see how you are going to solve this. So if you just start putting the values of n, like we just simplify, so then this is going to be a very difficult problem. So for example, I put n equal to 1, and then you put n equal to 2. So this will be 4 plus 6 plus this is 7. So tan inverse 1 by 7. So this becomes very cumbersome, and this goes till infinity. Okay, rather than your target should be, whenever you see a tan inverse sort of thing, to somewhere link them up with tan inverse A plus minus tan inverse B problem, right? This is the hint here. And if there is only one tan inverse, then obviously it should be somewhere either x plus y upon 1 minus xy, or it should be of the form tan inverse x minus y by 1 plus xy. This is what you should immediately start thinking. So let me just take the value that is ahead of summation, that is tan inverse 1 by n square plus n plus 1. Okay, now let's see how I'm going to rewrite this. Let's say 1 upon 1 plus n square plus n, and now if I take n common in the denominator, right? So this will be what? Okay, so just, yeah, this is not square, this is minus 1. It looks like a square, right? So this is 1 into n plus 1. Any problems till now? Obviously no problems. So अब जो मैं पढ़ा रहा हूँ, अब देखो, now this actually can be written as something like n plus 1 minus n. Again it is same, but now if you check this, this actually becomes this particular step. So that means I can write this as tan inverse n plus 1 minus tan inverse n. So this becomes a difference of two consecutive terms. So this series S is nothing but summation series is n is equal to 1 to infinity tan inverse n plus 1 minus tan inverse n. So people who have actually gone through my sequence series topic. So this is nothing but VN series, where the term is written as a difference of two terms. You just need to put the value of infinity in the bigger term and the smaller value of the limit in the smaller term. So this becomes nothing but tan inverse infinity minus tan inverse 1. So what is tan inverse infinity? Infinity is nothing but 1 by 0. So that is nothing but, yes, you get it pi by 2. This is pi by 4. So the answer we wanted is nothing but pi by 4 itself. So this is how you are going to solve this. People who are not comfortable with Vn, what they can think of this series as, so let's start putting the value of n as 1. So if you put n equal to 1, so what answers you are going to get? Tan inverse 2 minus tan inverse 1. Let's put n equal to 2, then what you will get? Tan inverse 3 minus tan inverse 2, right? So can you see that you are getting a definite pattern where each term is getting cancelled by its succeeding term, right? This is minus tan inverse 3. So this cancels out with this cancels out with this cancels out. All of these terms will similarly cancel out. The last term that will remain will be tan inverse infinity, and this particular term tan inverse 1. That is the reason we are saying tan inverse infinity minus tan inverse 1, which is nothing but pi by 4, which is the answer. Okay, so remember the pattern, how we have solved these kind of problems. So by this we come to the end of this chapter. As usually I will be sending the worksheets for you to practice on, plus you can again go and solve the exemplar of this particular chapter. Exemplar plus worksheets, I think this is more than sufficient for your JEE Mains level. More than sufficient, believe me. For JEE Mains, you do not require even to revise the tough concepts in this particular chapter. So for JEE Mains is sufficient. Plus, if you have any coaching material that you are going to, so coaching material, then you can practice that also. But I suppose the time that you people have will not provide you to do each and everything. So then do not do the coaching material. What you can do is you can revise your class notes. That is the thing that you should do on a regular basis. Revise class notes wherever, whatever you have studied. That is important because you know them the best at this point of time. All right. Okay. And for the NCRT, as usually, you can go and watch the solutions online on our channel again. All right. So I'll see you with the next topic then. Good night for today. Okay. Keep learning, keep studying.